Welcome back to Chapter 9. We are still looking at the area of different shapes. Last time, if you recall, we looked at the area of a triangle, a rectangle, and a parallelogram. A rectangle was base times height as well as parallelogram, and the area of a triangle was 1/2 times base times height. We're going to look today at trapezoids, rhombuses, or rhombi, and kites. And we'll start with the area of a trapezoid. If you'd like, you can break it up into a rectangle and two triangles, as you see, and find each of those individually, or you can find the area of a trapezoid using this formula. So a trapezoid has two parallel sides. We're going to call those base 1 and base 2. And then it has these slanted pieces. And then anywhere to go from base 1 to base 2 at a right angle is the height. So it could be there or it could be here. As long as it's going from base 1 to base 2, that is your height. So the formula for this is 1/2 or 0.5 times the height times base 1 times base 2. I like to write it like this. Base 1 plus base 2 first to remind me to do that first. That is because the order of operations, those parentheses are always first. So I just kind of write it first to help me remember. So what we're going to do is looking at these, I'm going to give you the answer. And if you would like to see if you can get them before I do, that'd be great. So the first one is 125 feet squared. You can pause the video if you'd like. The second one is 59.5 yards squared. This one is 59.57 inches squared and 48.35 centimeters squared. So if you'd like to pause and work ahead, go for it. I'm going to get started. Again, if you'd like, you can break this up into a rectangle and two triangles and find each one individually, but I like to use the trapezoid formula. So that formula is 1/2 times the base 1 plus base 2 times the height, which in this case, base 1 is 9, base 2 is 16, and the height is 10. You could type that all into your calculator at once if you'd like. Don't forget to do your parentheses first. And if you type that all in, you will get 125, and the unit would be feet squared. And let's check and make sure we got that right. We did indeed. I got a couple wrong last time I recorded this video, so I'm re-recording without my mistakes in here, just so you didn't have to listen to as long of a video. The next one is a little bit different. These bases are kind of sideways, so just think of it as the bases are still the parallel sides. It doesn't show that they're parallel, but they did say it was a trapezoid, so I'm assuming those are the parallel sides, not those two. So my area will be, again, 1/2 times base 1 plus base 2 times the height. The height here is that 7. So I'll do 1/2 times 13 plus 4 times the 7. And don't forget to do your parentheses first. So that's 17 times 7. Type that all in, or you can do the first two separately. Like the 1/2 times the 17 first if you'd like. I'm just typing it all in at once, and I got 59.5. Unit would be yards squared. Woohoo! Got it right. Okay, going down, this one, when I recorded it earlier, I assumed that this was a square because it looked like one, and I got it wrong. So I re-edited it so that you didn't have to take the time to see my mistakes. But I did want to let you know about those mistakes because they are easily made, and I didn't want you to be fearful of that. So I just thought, oh, that looks like a square. Make them all 8, but it is not a square. It is a rectangle. I can tell because of these right angles. This angle has to be 90 degrees so that those two add to 180. This one has to be 90, so they add to 360. So I was like, oh, a square. No, not necessarily a square. A rectangle, though, meaning this side and this side are the same. So that has to be 8 inches. This would then have to be 10 inches. And sneaky, I can find this height using the good old Pythagorean theorem. So we have 10 squared plus x squared, and that will equal the 11 squared. So I can do Pythagorean theorem. I'm gonna just switch to one color here. 10 squared is 100 plus x squared. 11 squared is 121. Let me double check that on my calculator. Yep, 121. Subtract 100 from both sides, and that gives me 21 square root. And x squared is, or x is 4.5826. Again, if you want the ACT answer, it would stay square root of 21 because 21 breaks down into 7 and 3. None of those have matches. So either x equals 4.5826 or the square root of 21. That it would be the ACT way. So now that I have the height, I can plug in my formula, and I would say the area is 1/2 times base 1 plus base 2 times the height. If I don't do the the ACT method, I will just do 18 plus 8 times the height is 4.5826. Type, this would be 26. And I would type that all in my calculator, and I would get the area to be 59.5735 inches squared, which is what I got. If you'd like to do the ACT way, it would be same thing, 1/2 times base 1 plus base 2 times height. And we would do 1/2 times 18 plus 8, but this time the height we would leave as the square root of 21. 1/2 times 26 times square root of 21. And I would say 1/2 times 26 is 13, and I would just leave it like this. Ooh, that's some bad handwriting. And the unit, again, would be inches squared. Same thing, that's just the ACT version. We'll do one more of these. Let's look here. I do not know the height, but your good old favorite, 30, 90, 30, 60, 90 triangle. I am going to remember my shortcuts that we did a long time ago, which said the long side of the triangle compared to the short side of the triangle. The short side was half, and this longer side was the short side times the square root of 3. If you don't want to do that, you can use trig. You can say sine of 30 equals opposite over hypotenuse. You would get, this being the opposite right there, you would get sine 30 to be 0.5. Multiply both sides by 10, and you would still get that x to be 5, whether you remembered your shortcut rules or you used trig. Then for this one right here, if you didn't remember those shortcut rules, the one that I just put as a y in there, you could do Pythagorean theorem. So you could say 5 squared plus y squared equals 10 squared, which would be 25 plus y squared equals 100. Y squared equals 75. Square root both sides, and the square root of 75 is 8.66, or if you like the ACT method, that would be 25 and 3, 5 and 5. Those are a pair that come out, and you'd still get the same thing. So I don't think we actually needed that. Y version, I just wanted to show you guys for ACT prep. So that confused you, don't worry about it. But we do need that X. So you can either use, oh, actually, I think we might have needed it. We did need the Y. Okay, so there you go. ACT method or the 8.66, whatever you prefer. So this is also 8.66 right here. So if the whole thing is 14, to get this pink section, I would do 14 minus 5 square root of 3, which would, ACT way, they would just keep it like this. Or you could do 14 minus 8.66, which is 5.33 or 34. So this is 5.34, and then so would this. That one amps it up a lot. So I could jump to my formula, 1/2 times base 1 plus base 2 times height. Not ACT way, we would say 1/2 times base 1 is 5.34 plus 14 times the height is 5. That would give you 19.34 times 5, and the area is 48.35, which is what I got. If you would like to do the ACT method, I'm going to show that right here. We would have the area is 1/2 base 1 plus base 2 times the height, and 1/2, and then the base 1 is 14 minus 5 square root of 3 plus base 2 is 14, and then the height is 5. So it'll give us the same answer. It's just going to look a little weird. We'll have 1/2 times 28 minus 5 square root of 3 times 5. I'm going to combine this and this to be 5/2 times 28 minus 5 square root of 3. Again, if you like this better, that's okay. I'm just trying to help you ACT people out. And then I would distribute. So the area would be 5 times 28 divided by 2 is 70. And then minus 25 over 2 square root of 3. So a little crazy looking. But again, if I type that in my calculator, 70 minus 25 square root of 3 divided by 2, I still get that 48.35. So this is what the ACT will do. Because they cray. No, they're just trying to get you to get really exact answers. So either way is fine. Okay, that is finding the area of a trapezoid. We're not going to stop there, of course not. We're going to look at the area of a rhombus and a kite. They are both the same. So whether it's a rhombus or a kite, your area is exactly the same. And it is just the, let's get my colors going, diagonal from the rhombus and the other diagonal of the rhombus. If you multiply those together and cut it in half. Same thing with a kite. The diagonal of the kite, the other diagonal of the kite, multiply them together and cut it in half. If you would rather find each triangle separately, be my guest. You can totally do that. Add them all up. Just seems like a lot of work to me. So I like this formula. It takes the diagonals and it multiplies them together and then cuts the answer in half, or multiply by 0.5. And that works for a rhombus or a kite. So again, if you want to work ahead, go for it. The area of this first one is 34 feet squared. The second one is 90 meters squared. The third one is 1,100 feet squared. And the fourth one is 62.45 inches squared. So let's do those. Okay, again, you could find each single triangle and add them all together, but I do not feel like doing that. So I'm going to use the formula. My diagonal 1 looks like it is 2 plus 6.5, so that is 8.5 feet. And my diagonal 2 is 4 plus 4, so that is 8 feet. And our formula was the area is 1/2 times diagonal 1 times diagonal 2. You can pick any colors. I switched my red and blue this time, I think. Yep, that doesn't matter. So the area is 1/2 times 8.5 times 8. And that gives you 34. Did I get it right? Yep, 34 feet squared. Each triangle is not necessarily the same. It looks like this one and this one are the same, and this one and this one are the same, but the ones on the left of the blue line and the right of the blue line are. So I wouldn't just take 34 divided by 4, but the whole thing is 34 feet squared. Okay, this one, we're going for 90 meters squared. So again, our area is 1/2 times diagonal 1 times diagonal 2. Diagonal 1 is 4 plus 11. So that gives us 15. And diagonal 2 is 6 plus 6, or 12. Gonna multiply all that together, and I should get 90. Perfect. Okay, let's amp it up a little bit. You know I like to do that. Make it a little bit harder. There we go. Okay, this one. So this is a rhombus, and I'm like, oh snap, they only told me this. They didn't tell me how long this was. But you gotta remember information we learned about rhombi, which was several chapters ago, that says this, if this is 22, so is this. It was one of the properties of a rhombus. It's been a while. So if this is 20, oops. If this is 25, so is this. It was a property that said if you cut, the rhombus, the diagonals bisect each other. I don't know if you remember that. It was earlier this year. It was around Spirit Week time. So now I have my totals, which say, again, area is 1/2 times diagonal 1 times diagonal 2. My area is 1/2 times 50 times, which was 25 and 25, times 44, which is the 22 and 22. If I multiply that, I get 1,100. Whoa. If you get bored of me talking, I'll just put an accent on. Hello, mate. I don't know, maybe not. Should I do the rest of it in a British accent? See if you're listening still. What do you think? Oh, snap. This one looks a lot harder. Maybe I'll have to go back to my regular accent for this. Yeah, I definitely need to. Okay, so they said it's a rhombus, I think. Yep, they said it's a rhombus. And so 10, if I cut it in half, this is my other diagonal, I know that this is 5 and 5. The problem is I have no idea what these green ones are. I know that they're going to be the same as each other, but I don't know what they actually are. If you remember, another property of a rhombus is that they meet in the center at a right angle. So that's actually useful for us. We can say this is x, and you know my favorite, Pythagorean Theorem, 5 squared plus x squared equals 8 squared. I'm going to switch to one color. I got 25 plus x squared equals 64. Ooh, I should be able to do that in my head, but I'm going to cheat and use my calculator. I got 39 square root. And if you are not doing the ACT method, you will get 6.2450. If you are doing the ACT method, 39 breaks down into 13 and 3. Which 13 doesn't break down at all, so that's as low as we can break it down. So we'd have that. Then we can find the area, which is 1/2 times diagonal 1 times diagonal 2. So it would be non-ACT method would be 10 for the diagonal, and then that's 6.2450. If I double that, I get basically 12.5. I'm going to be lazy there. And I would multiply it all out, and I would get 62.45. Unit would be inches squared, and that, let's double check, is indeed what we had. If you would like to do the ACT method, we will have the area is 1/2 times diagonal 1 times diagonal 2, which gives us 1/2 times 10 times, and then we'd have 2 of that square root 39. That is because, that is because the x was just one of the halves. So this was square root of 39. So is this. So together we have 2 of them. So I would just, boom, cancel those out and say the area is 10 square root of 39, and again, inches squared. It's a little bit more precise. I'm going to double check in my calculator that it gives me the same number, and it does. So that's probably our trickier one of a rhombus. Okay, that's all she wrote for areas today. We've so far done triangles, rectangles, parallelograms. So let's just do a little review. Triangles, the area is 1/2 times base times height. A rectangle is, the area is base times height, and a parallelogram, the area is base times height. The ones we did today was a trapezoid, which the area was 1/2 times base 1 plus base 2 in parentheses times the height. We did a kite, which the area was 1/2 times diagonal 1 times diagonal 2, and we did a rhombus, which the area is also 1/2 times diagonal 1 times diagonal 2. Again, the homework is a lot more application, so I will put answer keys up eventually, but there's a lot of application there. So do your best and email me if you have any questions. Have a great day. Bye, guys.